On the model number 2, that is measurement of directions and angles. In the previous class we discussed about the conversions of the whole circle bearing to the reduced bearing, or conversion of the reduced bearing to whole circle bearings. So start with the first one. Here the conversion from whole circle bearing to quadrantal bearing. First example, that is 22 degree 30 minutes. So where the bearings are in the whole circle bearing system. In the whole circle bearing, all the bearings are measured from the with respect to north direction only. Okay, just observing the value of this whole circle bearing, that is 22 degree 30 minutes. Suddenly you have to assume that this whatever the bearing is there, it is coming under the first quadrant. So just observe here, these are the two compasses with respect to WCB as well as a quadrantal bearing. Okay, suppose it is our 22 degree 30 minutes, it is lies in the first quadrant, okay, in the whole circle bearing. Similarly, in the quadrantal bearing also same, the 22 degree 30 minutes is present in the first quadrant. In the first quadrant, both whole circle bearing and quadrantal bearing measure from the north direction towards the east side. So directly you can write that RB is equal to WC, that is equal to with respect to value, that is 22 degree 30 minutes. So here you have to mention the on either side of the 22 degree 30 minutes, you have to mention the directions of the your measurement angle or bearing, that is north east. Okay, like that. So likewise you have to write the your RB value, that is N 22 degree 30 minutes east side. Second example, that is 170 degree 12 minutes. So this one is lies in the second quadrant, that is like this. Okay, so whatever the 170 degree 12 minutes is measured from the north up to with respect to line, that is value is our 170 degree 12 minutes. But the same line is present in the second quadrant. In the second quadrant, the measurement of a quadrantal bearing system is from the south towards the east side, that is like this. Okay, this is our RB and this one is our WCB value. So here we have to calculate this much of value. In the second quadrant, we have to calculate RB is equal to, our formula is 180 degree minus of WCB value. Put up the with respect to value, we will get the, that is south 9 degree 48 minutes east. So always you have to mention the directions of the bearing, that is south 9 degree 48 minutes east, and I have to mentioning the quadrantal bearing systems. Third one, 211 degree 54 minutes. By observing this angle bearing, it is lies in the third quadrant. In the third quadrant also WCB is measured from the north only again. So in the quadrantal bearing, the line is present in the third quadrant. So in this condition, the measurement of a quadrantal bearing, it is from the south towards the west side. Okay, so in that condition, RB formula will be RB is equal to WCB minus of 180. Put up the values with respect to WCB value minus of 180 degree like this. Then we'll get the with respect to RB value, that is south 31 degree 54 minutes west. Clear? Then similarly fourth one, it is lies in the fourth quadrant. Again this one is the WCB. So in the WCB quadrantal bearing system, again whatever the line is present in the fourth quadrant, it is measured from the north towards the west sides. So in that condition, our formula will be RB is equal to 360 degree minus of WCB. Put up the WCB value, we'll get the our RB value, that is south 31 degree 54 minutes west side. Actually it is north, so make it correction. This one is north 31 degree 54 minutes west side. Clear? Similarly, we have to converting the quadrantal bearing to the whole circle bearing systems. That is first one, that is north 12 degree 24 minutes east side. Again, as same it is, there are two compasses with respect to WCB and whole quadrantal bearing system. In the first quadrant, the measurement of a bearing from the both cases will be same. So directly we can write WCB is equal to RB, that is equal to 12 degree 24 minutes. Just remember that one. Whenever to mentioning the WCB value, don't mention the with respect to directions. Okay. Similarly, second one, yes, south 31 degree 36 minutes east. So just observe here, this is our reduced bearing value measured from the south towards the east, but in the whole circle bearing system it is measured from the same line measured from the north direction, that is like this. So we have to calculate this one. Our formula will be WCB is equal to 180 degree minus of RB. Put up the RB value, that is 31 degree 36 minutes. We'll get the our whole circle bearing value, that is 148 degree 24 minutes. Similarly, third one, that is south 68 degree 6 minutes west. So just observe in this diagram. So this is our line. The whatever the bearing is measured from the south to west side, this is our quadrantal bearing or reduced bearing. But in the same condition, the same line is measured in the by using a whole circle bearing system from the north with respect to line, like this. So we have to calculate the this much of bearing. So here our WCB formula will be 180 degree plus of quadrantal bearing value or reduced bearing. Put up the respective value, we will get the our total value WCB is equal to 248 degree 6 minutes. So again, sorry, so we have to consider this sign convention is again positive. Okay, already I have written here, so make it correction, here it is positive. Then last, fourth one, north 5 degree 42 minutes west. So here same, it is measured from the north to west side, but in the WCB system it is measured from the north in the clockwise direction up to the line. So in that condition our formula will be WCB is equal to 360 degree minus of RB, that is equal to 360 degree minus of 5 degree 42 minutes. Difference these two will get the our WCB value, that is 354 degree 18 minutes. Okay, these are the conversion from the whole circle bearing to the quadrantal bearing. Next, we have to solve some problems on calculation of forebearing and back bearings. Okay, so you just remember that one. The calculation of back bearing is equal to forebearing plus or minus 180 degree. So use the plus sign if our forebearing is lesser than the 180 degree. Use the minus sign when it is forebearing is greater than the 180 degree. Okay, remember that one. Plus sign is our forebearing is lesser than the 180 degree. Then minus sign is our forebearing is greater than the 180 degree. So first one, the bearing of AB line, it is 12 degree 24 minutes. Now we have to calculate the back bearing of the AB, that is equal to 12 degree 24 minutes. Here the whatever the bearing of AB is lesser than the 180 degree, you have to use the plus 180 degree. Okay, just add them, we'll get the back bearing of AB is equal to 192 degree 24 minutes. Similarly, second one, second line, that is BC, that is equal to 119 degree 48 minutes. So again same, the whatever the back four bearing of the BC is lesser than the 180 degree, so you have to use the plus 180 degree. So back bearing of BC is equal to 119 degree 48 minutes plus 180 degree. Add them both, will get the back bearing of the BC is equal to 299 degree 48 minutes. Similarly, third one, CD is equal to 266 degree 30 minutes. So our bearing of CD is equal to greater than the 180 degree. So in that condition, our back bearing of CD is equal to 266 degree 30 minutes. It is greater than 180 degree. You have to use the minus sign 180 degree. Difference these two will get the back bearing of CD is equal to 86 degree 30 minutes. Similarly, same, the back bearing of DE is equal to 354 degree 18 minutes. So you have to deduct the minus of 180 degree, will get the back bearing of DE is equal to 174 degree 18 minutes. Then the above first four examples are related to the WCB or whole circle bearing systems. But in the fifth one, the line PQ is equal to north 18 degree 0 minutes east side. This is in terms of quadrantal bearing systems. So in that condition, our solution is back bearing of PQ is equal to, you can directly write yes 18 degree 0 minutes east. Just you have to change the directions of the our bearing. That is, if it is north, you can write directly south. If it is east, you can directly write here it is actually W. Okay, just change the our directions. The whatever the value will be there, it you can write as same as it is. Okay, so this one is W. Actually, this is W. Okay. Similarly, next one, that is QR is equal to south 12 degree 24 minutes east. So for writing of the back bearing of QR is equal to, just interchange the with respect to sign convention. Here it is south, here it is east. So instead of south, opposite direction direction is north. For east, it is west. So you can write directly north 12 degree 24 minutes west side. Clear? So if they give the back bearing of the lines, you have to find out the fore bearing of the line. Okay, same formula we are using. If the bearing of AB is 75 degree 48 minutes, the bearing means it is our back bearing. So we have to calculate the fore bearing of the AB line. Okay, so our fore bearing of the AB is equal to, so it is 75 degree 48 minutes. It is lesser than the 180 degree. So add the 180 degree, will get the fore bearing of the line AB, that is equal to 255 degree 48 minutes. Similarly, line BC is equal to 135 degree 54 minutes. Here also same, it is lesser than the 180 degree. So you have to add the 180 degree, will get the back bearing of BC is equal to 315 degree 54 minutes. Coming to the last example, CD is equal to 209 degree 10 minutes. So 209 means what? It is more than the or greater than the 180 degree. So our fore bearing of CD is equal to 209 degree 10 minutes minus 180 degree, will get the fore bearing of 29 degree 10 minutes. Okay, actually it is, yeah, this one also, yeah, that is fore bearing of BC, fore bearing of CD. So here Same formula you have to use that one for calculation of the forebearing of the line AB, BC and CD. So you have to remember that one. Use the plus sign if the bearing is lesser than 180 degree. Use the minus sign if the bearing is greater than 180. Then we will get the with respect to forebearing as well as a back bearing of the line. So these are the simple basic problems in the compass surveying. Next we discuss about the declination. As you know that there are two directions are there. One is or two meridians are there in the with respect to magnetic as well as a true meridians. Okay. The always you know that one the magnetic meridian and true meridian may not coincide with each other in a one place. Always small difference between the magnetic meridian as well as a true meridian. Okay. So just observe these are the diagrams. So the horizontal angle between these two meridians is known as a magnetic declinations. So magnetic declination means what? First you have to come to know that magnetic meridian as well as a true meridian. These two lines will not coincide with each other in a one place. Whatever the angle between these two meridians, okay, the angle between the magnetic meridian and true meridian, this meridian is or this is called as a magnetic declinations. Just observe here, this is our true meridian and this one is magnetic meridian. These are the two with respect to directions. The angle between these two lines, whatever the value is there, this value is called as our magnetic declinations. Also it can call simply that is declination. Okay. Depending upon the directions of the declination may be positive or negative. If magnetic north is towards the east side, from the north is known as a easter or positive declinations. Suppose our magnetic meridian it is towards the west side, that is like this. It is in that condition this declination is called as a western declination. Then the value of the declination it will always not same in the same places. It is continuously it is changes from the time to time. Depending upon the changes of these one, they are classified the 4 that is diurnal variations, annual variation, secular variation and last irregular variations. These are the 4 classification of the or 4 variations in the declination system. Now discuss about the determination of the true bearing. True bearing means what? Whatever the bearing is measured from the true meridian with respect to line. So here the whatever true meridian it is only used in the when I have to conducting the very important survey works. In that condition they are referring the true meridian for the marking of the with respect to places. So here for calculation of the true bearing, the general formula is that is magnetic bearing plus or minus declinations. For calculation of true bearing, the very simple formula that is magnetic bearing plus or minus that is declinations. So when to use the plus sign as well as a negative sign. So use the plus sign if the declination is towards the west. Okay, use the plus sign if our declination is towards the east. If use the minus sign if the declination is towards the west side. But one condition, the using of these plus sign and minus sign with respect to east and west, this is only applicable in the whole circle bearing systems. If the whatever the bearing is they are given in the whole circle bearing system, then with respect to observe the declination value, whether it is towards the east or west, depending upon that one, you have to use the sign conventions. But the whatever the bearing is measured in the reduced bearing system, in that condition you have to draw the with respect to diagram with respect to true meridian line as well as a magnetic meridian line. Then with respect to bearing in the system of the reduced bearing, then you have to calculate the true bearing from the with respect to diagram. Okay, so on that one we have to solve the one or two examples for calculation of the declinations. So just one first example, the magnetic bearing of a line is 48 degree 24 minutes. Calculate the true bearing if the magnetic declination is 5 degree 38 minutes east. Okay, just what they are given, they are given the magnetic bearing of a one line, that is 48 degree 24 minutes. So on either side of this bearing, that is 48 degree 24 minutes, they are not mentioned any directions. So directly you have to come to know that the whatever the given bearing is in terms of it is in whole circle bearing systems. Then they are asked that you have to calculate the true bearing if the magnetic declination is 5 degree 38 minutes towards the east. So for solution of this one, okay, just observe here, they have mentioned that declination is towards the east side. Okay, so this is our true north, the whatever the plus and black line is there, these are the true norths, and this one is our magnetic north. So they are given the magnetic bearing, the whatever the, there is a one line, it is measured from the magnetic north only. So the angle between this TN and magnetic north, this is our magnetic declination, it is towards the west side. So this value is, that is declination, that is 5 degree 38 minutes east. Now the line is presented like this, the whatever the 48 degree 24 minutes, it is measured from the magnetic north towards the with respect to line like this. So this is our theta or bearing. So that is our theta value is 48 degree 24 minutes. Now we have to calculate the true bearing. True bearing means what? The whatever the bearing is measured from the true north to the with respect to line, that is like this. The whatever this one is there, this is our true north, it is measured from the true north to the with respect to line AB. So we have to calculate of this one by observing this diagram. You have to add the theta plus with respect to declination value, or you can use the formula, that is true bearing is equal to magnetic bearing plus or minus declinations. So here magnetic bearing is value is 48 degree 24 minutes. Our declination is towards the east side. So if it is declination is towards the east side, you have to use the plus sign convention. So you can write 48 degree 24 minutes plus 5 degree 38 minutes. Add them, you will get the 54 degree 2 minutes. Okay, this is our true bearing of a line AB. Similarly, I am solving the one more problem on the calculation of declination if they are given the bearing in terms of quadrantal bearing system. Just observe here, magnetic bearing of a line AB is south 28 degree 30 minutes east side, and calculate the true bearing if the declination or magnetic declination is 7 degree 30 minutes east side. Okay, if the bearing is given in the quadrantal bearing, you must draw the with respect to diagram. Okay, don't apply the with respect to previous formula. So this is our true north. So they have mentioned that one, the magnetic north is like this. Okay, that is 28 degree 30 minutes. So this is our difference of the angle of bearing between the true north and magnetic north, that is our declination. Okay, declination is actually it is west side, sorry, this is west side. That's why I am drawing the magnetic north towards the west side. Okay, the whatever declination value is there, that is 7 degree 30 minutes west side. So now this is our line AB. So the whatever the bearing is there measured in the from the south towards the east. Okay, so I am just extending this magnetic north line like this dotted line. The whatever dotted lines are there, this is the extending of this magnetic north. So that is, this will be act as a magnetic south. Okay, so in that condition, the angle from the magnetic south towards that line, this bearing is how much it is, our theta value, that is 28 degree 30 minutes east. Now we have to calculate the true bearing. So it is in the quadrantal bearing system. If the line is present in the second quadrant, the whatever the bearing is measured from the true south to the with respect to line, that is like this. Okay, this is our true bearing. For calculation of this one, how will calculate? We have to add this much of angle plus this theta value. So what is the value of this one? The bearing of this one from the true north south to the with respect to magnetic south. This is opposite angles. Okay, so the angle is as equal to the D only. Okay, so directly you can use formula magnetic bearing plus 5 our declination value. Actually it is, I am not written here. So 28 degree 20 minutes. So adding up the both declination and bearing. So plus our declination value is 7 degree 30 minutes. Simplify this one or add these two, we'll get the 50 minutes plus 35 degree, or simply it is 35 degree 50 minutes. Okay, this one is fine. Okay. So you can easily calculate the true bearing of a line in the condition of the whatever the magnetic bearing is given in the quadrantal bearing systems. Next one is local attraction. So again I am continuing with the local attraction. Okay, again this one is very important. You must understand what is the meaning of local attraction. Then we have to discuss about the how to find out the local attraction and how to eliminate the effect of the local attraction while measuring the bearings in the field. Okay, first you have to understand what is the meaning of local attraction. A magnetic meridian at a place is established by a magnetic needle which is uninfluenced by other attracting forces. It means you know that in the compass instrument, the whatever the needle is made up of a magnetic material. If the whatever the any attracting material, maybe it will be steel or any ranging rod, come nearer to the our compass instrument, the whatever the needle is there, it is attracted towards the with respect to ranging rod or any watch steel watches are you are holding that one nearer to the compass instrument. The whatever the needle will be, it is attracting towards the with respect to material. Then what will happen? The whatever the true magnetic north and south direction will be, it is deflected. Okay, it will not show the with respect to accurate magnetic north and south directions. So our local attraction is a term used to denote any influence such as the above, which prevents the needle from the pointing to the magnetic north in a given locality. Okay, local attraction means what? The whatever the magnetic needle is, it is not showing the with respect to magnetic north and south direction. That is why because of influence from the any other materials. Okay, so the what are the materials? Okay, some of the sources of the local attractions are, one is magnetite in the ground, sorry, magnetite in the ground, okay, or wire or electrical wires on above of the compass instrument, or any steel structures or railroad rails, okay, iron coil, keys, metal buttons, okay, chains or steel tape. Okay, these are some of the examples of the material come nearer or contact with the our compass instrument. The whatever the magnetic needle will be, it is deflected, attracted towards the that material. Then what will happen? It will not show the magnetic north and south direction accurately, or simply it is magnetic north directions. Okay, these are some of the sources of the local attraction. Now, how to find out the local attraction after observing the bearings in the field? That is very simple. Just observe the with respect to lines, forward bearing as well as a back bearing. Okay, the whatever the lines you have measured in the field, you have to observe the, if it is there is a one line AB. Okay, you have to measure the forward bearing of AB. Okay, suppose this is forward bearing and this one is back bearing. Okay, just observe these two bearings, that is forward bearing as well as a back bearing of the AB line. Okay, after that always you come to know that the difference of the back bearing as well as a forward bearing, it is equal to the 180 degree. Okay, always difference of the back bearing as well as a forward bearing, it is equal to the 180 degree. If there is no, the whatever the value is equal to the 180 degree, you have to come to know that the whatever these two stations are there, it is free from the local attractions. Means there is no effect of the local attraction, but you have to observe the other any instrumental errors are present or not. Okay, if the forward bearing and back bearing are difference of these two will get the equal to the 180 degree, then you have to come to know that it is these two stations are the free from the local attraction. Then you can go for the observation for the any other instrumental errors are present or not. Okay, so here our aim is only local attraction, so you have to just difference the with respect to forward bearing and back bearing, then it is equal to 180 degree, so our stations are free from the local attraction. Suppose the whatever the difference of the forward bearing and back bearing is not equal to the 180 degree. Maybe it will be more than 180 degree or maybe it will be lesser than the 180 degree. Then we have to come to know that these two stations will be affected by the local attractions. Okay. Then later we have to remove the with respect to local attractions value. Okay, so next we will discuss about the elimination of a local attraction. For elimination of a local attraction, there are two methods are there. One is by observing the forebearing and back bearing. The one more it is by calculating the included angles. So for here I am discussing only by observing the forebearing and back bearing. Okay. So instead of explaining the with respect to method, I will directly solve the one problem. Then you will come to know that the with respect to steps for the resolving the local attraction problem. Okay. I will explain later these two. Directly I am going to the example. Okay. Today I will solve the only one example and tomorrow one more example. Okay. So example 1. Just observe here. The following bearings were observed while traversing with a compass. Okay. Okay. These are the with respect to forebearing as well as a back bearing of the lines A, B, B, C, C, D and D. Okay. So here we have to find out the which stations are affected by the local attraction and determine the corrected bearings. Okay. So whenever to solving the local attraction problem, they are giving the forebearing as well as a back bearing of the with respect to lines. Then you have to find out the what are the stations are affected by the local attraction and then determine the corrected bearings of the with respect to lines. Okay. So start with the solution. So first step for this solution of the local attraction problem, you must difference between the forebearing as well as a back bearing. Okay. So first one line AB. Here they are given the back bearing as well as a forebearing. Difference of these two will get the 180 degree 25 minutes. So the whatever the line AB is there, it is affected by the local attraction because of the whatever the difference of the forebearing and back bearing, it is not equal to the exactly 180 degree. Okay, it is 180 degree 25 minutes. Similarly, second line BC, again difference of these two, we are getting the 180 degree 10 minutes. Again here also it is there, it is not equal to the 180 degree, then these are affected by the local attractions. Similarly again third one CD line, we are getting the lesser than 180 degree, again this line also affected by the local attractions. Okay. Then last DE, difference of these two will get the exactly 180 degree 0 minutes. Then you have to come to know that this is not affected by the our local attractions. It means the whatever the bearings measure from the with respect to D station as well as a E stations are the free from the local attractions. Okay, just observe, you can write one sentence. Difference between the back bearing and forebearings of a line DE is exactly equal to the 180 degree. Hence, the both stations D and E are free from the local attraction and all other bearings measured from these two stations are also correct. Okay, it means, so this is DE, this is our DE, it is station from D to E and this is E to D. So this bearing is measured from the station E towards the D and this bearing is measured from the, our instrumentation is D towards the east. These two bearings are correct. Similarly, the what are the back bearing of CD? Okay, the what are the back bearing of CD is equal to there. It is measured from the station D. Our instrument is D towards the bisecting the C station. So it is measured from the D station. So the whatever the these bearing are, it is also correct. Okay. After finding out this one, you have to come to know that these two are stations are the free from the local attraction from which whatever the bearings are measured from these two stations are free from the local attractions. From D station, this one bearing and this one bearing both are measured from the D station, so it is these two bearings are correct. Similarly, from E station they have measured the 144 degree 48 minutes. This is also correct bearing. No, means these are the free from the local attractions. Okay, this is the first step. Next, second step. So I am mentioning the one table here. The whatever the corrected bearings are there, I am marking the with respect to these colors. Okay. Now we have to calculate the, if the back bearing is this one is correct, by using this one we can calculate the fore bearing of CD. Okay, just we already know that this one is correct wrong, this one is also wrong, this one is also wrong. Yes, but already know the back bearing of CD, that is 209 degree 10 minutes is correct. By using this one you can calculate the fore bearing of CD. Okay, so just we have to write the one sentence here, that is like this: observed bearing of DC is equal to 209 degree 10 minutes. So you can write it is this bearing is correct, so I am writing the in bracket it is this bearing is correct. Now you can calculate the fore bearing of CD, or correct bearing of CD is equal to, that is fore bearing, correct bearing back bearing of CD minus of 180 degree. So back bearing is 209 degree minus of 180 degree. So simplify this one, we'll get the 29 degree 10 minutes. This value is there. This is our fore bearing of CD. This value is correct. Clear? Then now observed bearing of the CD or at C is equal to how much it is, 29 degree 45 minutes. Now we have to calculate the what is the error at the station of C here. Okay, at the station we are measuring the one fore bearing, one more it is back bearing of the BC line. So the what is the error at the this C stations? How to calculate? This is our formula. Error at C station, that is observed bearing minus of correct bearing. So just we have calculated the correct bearing at the station of C. So already measured back bearing is 29 degree 45 minutes. Put up the with respect to value, we will get the, that is plus 35 minutes. Just remember that one. Always use the, for calculation of the error at C is equal to observed bearing minus of correct bearing. Observed means the whatever given in the table, correct bearing is whatever you have calculated the previous one. Okay, then we'll get the error at C station is plus 35 minutes. If error is plus, our correction will be always negative. Clear? Now if C station it is correction is minus 35 minutes, so we can calculate the back bearing of BC here, this one. So this bearing is measured from the C stations. So our correction is already we know that one. So this correction is applied at the whatever the bearings are measured at the station of C. So correct bearing of CB or back bearing of BC is equal to observed back bearing of BC minus of correction at C stations. Observed back bearing is 277 degree 5 minutes minus of, with respect to sign convention, directly I am taking with respect to sign, minus 35 minutes. Simplify this one, we are getting the 276 degree 30 minutes. So this bearing is our correct back bearing of BC. If back bearing of BC we know that one, by using that one we can calculate the fore bearing of BC directly. Back bearing of BC minus of 180 degree. Why I am using the 180 minus 180 degree? the whatever the back bearing is more than the 180 degree. Simplify this one, we are getting the 96 degree 30 minutes. So actually observed is 96 degree 55 minutes, but our calculated or correct bearing is 96 degree 30 minutes. Difference of these two will get the correction at station B. So observed back bearing of BC or at B is equal to 96 degree 55 minutes. So I have written the again corrected bearings here. Remaining is this one. Now error at B can calculate by using again formula observed bearing minus of correct bearing. Observed is 96 degree 55 minutes. Then correct bearing is just we have calculated in the previous slide, that is 96 degree 30 minutes. Difference these two will get the plus 25 minutes. So if error is positive, our correction is always negative. By using that one, we have to calculate the back bearing of AB. Okay. So back bearing of or correct bearing of BA or back bearing of AB is equal to observed back bearing of AB minus correction at the station B. Put up the with respective value 226 degree 10 minutes minus 25 minutes. Fill up all the things, then simplify this one, we'll get the 225 degree 45 minutes. This is our correct back bearing of line AB. Then last, that is bearing of AB line, that is already correct back bearing of AB just to have calculated minus of 180 degree. Put up with respect to value like this, simplify this one, we get the 45 degree 45 minutes. Now whatever the calculated bearing of AB is there, it is same as the our observed bearing of AB line. Then you have to come to know that our station A is also free from the local attractions. Initially we have just observed that one, we are assuming that one, the whatever the line AB is there, it is not affected by the local attraction, but at the calculation time we are getting the A station is free from the local attractions. Okay, these are the some calculation steps are there. Follow that one. You have to solve this one again, and we'll continue in the next class. Clear?